It's usually pretty obvious to people what math is: numbers, counting, shapes, and solving problems. But when we look more into it, it becomes a bit more mysterious. What is the number 42 really? Is math an art or a science? I plan to explore all these different philosophical problems in math in this series. What is math? But I think a good place to start is by fleshing out my personal philosophy of teaching mathematics to set the groundwork for this discussion. For thousands of years, mathematics has been an esoteric and secretive venture reserved only for the initiated. In the 6th century BC, the Divine Brotherhood of Pythagoras kept disclosed the existence of the 12-faced dodecahedron, which, to them, represented the ether permeating all of space. In 1637 AD, René Descartes remarked in The Geometry that he had erased all his laborious calculations, quote, so as to grant the reader the enjoyment of discovering them for himself, end quote. When non-Euclidean geometry was being simultaneously discovered in Russia and Hungary during the 19th century by Nikolai Lobachevsky and Janos Bolyai, its earth-shattering and paradigm-shifting consequences had already been discovered, collecting dust on Carl Friedrich Gauss's shelf from years prior. Today, in the 21st century, mathematics has never been more accessible, more available, and in plainer view of the public eye. And yet, paradoxically, it is more mysterious and hidden than at any point in history. Everyone is required to learn math in primary and secondary school. They believe that they know what mathematics is and how it can be utilized in the real world. Even the staunchest math phobe will pay lip service to what the physicist Eugene Wigner called, quote, the unreasonable effectiveness of mathematics in the natural sciences, end quote. But if there's anything that the average person knows about mathematics, it's that they are not a math person. This is often the greatest stumbling block for the uninitiated in their study of mathematics. But this discipline is not something that falls out of the sky, and it was not developed in a vacuum. Mathematics is a traditional subject, handed down from one generation to the next. Its problems, constructions, solutions, theorems, and notations are guided and gifted to us by history in a way which, properly understood, can humanize a cold and dead subject of seemingly brute facts and calculations. To truly become a math person is to practice under careful supervision by a trained practitioner and keeper of these secrets. My philosophy of teaching and learning mathematics, which I share with my students on the first day of class, is derived from the tradition of Euclid, Isaac Newton, and John von Neumann. In Alexandria, Egypt, around 200 BC, Euclid was tutoring King Ptolemy I. When the king complained to Euclid that math was too difficult, he asked if there was an easier way to learn. Euclid famously responded, quote, "Sire, there is no royal road to geometry," end quote. I warn all of my students to steer clear of tutors who promise to make math easy. They are surely just trying to take their money. Mathematics must be studied in the same way that Isaac Newton studied the geometry of René Descartes. Newton explained, quote, "I opened the geometry and read it until it didn't make any sense. Then I started from the beginning and read it again until it didn't make any sense. I repeated this process until I understood the entire thing," end quote. A student must fight the text and material, scrutinize it, question it, try to prove it wrong. But more than anything, you must force the material into your mind repeatedly until your cognition is conformed to the truths under investigation. This is the most necessary part of learning mathematics. As John von Neumann teaches us, quote, "You do not understand anything in mathematics, you just get used to it," end quote. Because mathematics is esoteric and a purely mental experience that you must be initiated into, there is no reason to be surprised that students are confused or that they don't understand something. What is at first dark and mysterious becomes routine and subconscious through repeated exposure. What happens between these two experiences is both inexplicable and frustrating, but it shapes our character in the process. We study mathematics so that we can become better people. In the 15th century, there was a debate held about whether mathematics as a subject should be taught at the university at all. It was argued that students should only be taught what qualified then as science. According to Aristotle's definition, science requires more than formal deduction. Mathematics is a purely deductive art and did not rest its foundations on empirical knowledge. Although observations through calculation have played a pivotal role in the discovery of mathematical theorems, our sensory perceptions often prove to be a stumbling block through the treacherous rigor of formal logic. As a quick example, the first proposition in Book 1 of Euclid's Elements has a conspicuously hidden logical gap, which is filled in by a subtle and obvious picture. We can only imagine an alternate universe where math was removed from the university. Those who argued about keeping math in the university clearly won this argument. They argued that, although math doesn't fit the Aristotelian definition of science, studying mathematics trains the mind to think scientifically, deductively, and methodically. Mathematics is an indispensable tool and field of study for the formation of virtuous and scientific scholars. The word mathematics, coming from ancient Greece, can be best translated as the lesson or the science concerned with learning. As I warn my students, if you are not studying, you are not doing mathematics. It is fundamentally the responsibility of the professor to impart the lesson to their pupils, because math doesn't fall out of the sky. However, it is also the pupil's responsibility to work through the exercises given to them, because we do not learn math with our ears and eyes. Mathematics is learned through the hand. Countless problems must be mastered to achieve any success. However, they can't just be randomly generated problems from some textbooks. By carefully choosing specific problems, an instructor can set up all the logical traps for the students to be caught in, to help them build immunities from fallacies and to see what is really going on. Sometimes this requires doing an extremely difficult problem to not hallucinate any weird coincidences that involve the law of small numbers. Sometimes this requires having an even simpler problem, which has a subtle detail that the students will overlook completely. It is the responsibility of the instructor to know when to use each kind of problem, to prepare their students for the logical trials and traps that they will find in their everyday lives. I define mathematics as that which makes sense, something that can be understood. Things that make sense only make sense because they exhibit an underlying mathematical structure that our minds perceive. A mathematician is a maker of sense, preferring reason over opinion. If what I am communicating does not make sense, and if I am not being understood, then I am failing at my duty to be a maker of sense, a mathematician in the fullest sense of the word. It is my responsibility as a bearer of the tradition handed down once to Euclid, to Descartes, to Newton, to Gauss, and to von Neumann to present the whole picture, the whole approach, the whole method of initiation to the beautiful world of mathematics. If you enjoy this content, make sure to like, share, comment, subscribe, and hit the bell for notifications. If you want to take your knowledge of math to the next level and/or join a community of math lovers, please head over to courses.modernmathacademy.com to become a member of the Academy and start learning today. From me, Dr. W.